So let's talk about flexible thinking. Flexible thinking is a term people often use to refer to a child's ability to think about things in a different way. And it's essential for true learning, right? Being able to learn something in one context and then apply it in another. But flexible thinking becomes increasingly difficult as we gain expertise. As we become experts, it's really hard to break our focus and challenge the conventional views in our work. And this is true in all disciplines. But you should know that I am a neuroscientist. So by definition, my job is to study the function and dysfunction of the nervous system. And I do all of this in mouse models of neurological disease. So I'm really coming at this from a scientific view. And in theory, science should be the pinnacle of all flexible thinking. It's our entire job as scientists to gather and integrate information in order to innovate. But I myself have had a long history of conventional thinking. However, I've also had the experience of being a flexible thinker, and I found this much, much more rewarding. See, for the past 3 years, I studied a childhood neuromuscular disorder called spinal muscular atrophy. And in that disease, a special type of neuron in the spinal cord, called a motor neuron, it dies. And the job of the motor neuron is to send signals out from the spinal cord to our muscles, ultimately allowing us to move. And so pretty clearly, when that neuron dies, those signals are no longer being sent. And that leads to muscle weakness, paralysis, and even death in the most severe and youngest patients. And this motor neuron to muscle circuit, it's very delicate. It's very complex. But understanding it is really essential for understanding what's happening in neuromuscular diseases. And as scientists, we're really good at looking at this circuit in parts and pieces. We're even really good at taking snapshots of it over time in dead tissue. But we struggle, mainly due to technical difficulties, on being able to work with this circuit while it's fully intact and alive. And therein lies my problem. I want to work with this circuit while it's intact and alive. But this circuit's very small. It can't be seen without a microscope. And the average neuroscientist like myself is not going to be able to dissect it out, keep the whole thing together, and then also keep it fully functioning. So I couldn't alter the system that I had, so I decided I needed a new system. Now, when you think of neuroscience, you probably think of the brain and maybe even the spinal cord. But there's nerves and neurons throughout your entire body. And conventional thinking in neuroscience would say, if you want to study the brain, use the brain. If you want to study spinal cord motor neurons, you should probably use spinal cord motor neurons. But this time I had to go outside of convention. And this time, I used the enteric nervous system, this beast of a nervous system in your gut, to study what was happening with the spinal cord. So what you need to know about the enteric nervous system is that it has a shit ton of neurons. A shit ton. Nearly as many as your spinal cord. And they're, fortunately for me, most of them are motor neurons, which is exactly what I'm looking for. And they're arranged in these beautiful structures called ganglionated nerve plexuses. They look like a fishing net. And that net is cast out and sandwiched in between two muscle layers. And just like our spinal cord motor neurons talk to our skeletal muscles, the motor neurons in the gut talk to the gut muscles. And they tell them to contract and relax, and they ultimately lead to digestion. And so if you think about it, this is perfect for me. I have the two elements I need, motor neurons connected to muscle. But it gets even better. Because what I haven't told you is that the enteric nervous system can function largely without any input from your brain. That's right. You can take the gut out of a mouse all the way from the esophagus to the rectum, which is what you're looking at here. Put it in a dish, watch it wiggle around, and keep it alive for hours. And if you think about it, this is perfect for me. This is a solution to my problem. I have motor neurons that are attached to muscle still, and it's alive and functioning outside the body. And this is a system I can test on, and this is a system I can work in. But I gained something else from this project, and besides just creating this model to study the disease, getting raw data from this model, and a really cool wiggly gut video, which is really cool. But that was an appreciation for flexible thinking. So I had a problem, and only flexible thinking really led me to a solution. It allowed me to take something old, so the enteric nervous system's been around forever, and use it in a new way. It allowed me to take what I considered trash. I studied the brain and spinal cord. Who cared about the gut? And use it as my new treasure. And so you might be thinking, what can flexible thinking, how does this apply to me? What can it do for me? In flexible thinking, the very first thing it will do is it will allow you to generate possibility. So if we think of other examples in science, say the scientists that are taking a patient's own skin cells and transforming them to attack brain tumors, or even those growing organs, human organs outside of the body in hopes for transplant one day. I think we can agree that those people are really pushing boundaries and generating possibility. In my own work, I re-innovated a system we already had to discover a new way of looking at neuronal function that was previously too difficult, generating possibility. The other thing flexible thinking will do is it will push you out of your comfort zone and force you to learn a lot. And so, again, I studied the brain and spinal cord. The gut was an entirely new territory, very much out of my comfort zone. And to study it, I really had to take an interdisciplinary approach. Sure, I used neuroscience and gastroenterology, but I had to throw in a pinch of pathology and a sprinkle of microbiology to be able to use the system correctly. I was forced to learn a lot, and I was greatly rewarded for that. And you can think about funny examples in science of flexible thinking. I mean, who would have thought a failed cardiac function drug in combination with flexible thinking, serendipity, and really great marketing would have given us Viagra? And to some, that's a miracle drug. But maybe your flexible thinking experience won't give you the next miracle drug. But what it will do is it will improve the perspective of your work, no matter what that work is, even outside of science. And it will inspire others. And so my ask of you today, I challenge you to really challenge your conventional views, see through them, and be aware, remain aware, that oftentimes the very best ideas come from thinking flexibly. Thank you.